So if you're here, everyone, hello again. Make sure you smash that chat button. Vrudant is alive. Congratulations. If you haven't already said hello on the chat, you can turn your microphone on, say hi. I hope you're doing well. Who has finished lab test 1? Have you finished lab test 1? If so, how did you go? Was it easy? Was it difficult? Were there any surprises? Let me know. How did you go? Was it easy? Was it what you expected? That's great. Yeah, minimum 80, I think. If you got over 80, then that's a good thing. Well done. All right, well, in today's tutorial, I thought we could talk about complex numbers. So just let me know, has everybody seen complex numbers in the algebra lectures? Let me know. Have you seen them in the algebra lectures yet? Okay, Vrudant says yes. All right. So let me share my screen. I thought we could do some simple questions, and then maybe we can move on to maybe some discussion, or you can ask me anything if you want. So let's see how we go. Yeah, Jen Wu, it is hard sometimes, and it's accuracy is important, but it's easy to make mistakes. And I mean, you know me by now. In my lectures, I make a lot of mistakes. So I thought we could maybe talk about the conjugate and maybe do some of these questions here. Okay. So I thought I would just start with 6A. Let me know how things are going, either in the chat or you can turn on your microphones and let me know. Okay. So I'll just kick things off and we can just do this together. Oh, hang on. I don't have my document camera turned on. So just let me put that in the right spot. And now I should be able to share it. There we go. All right. Okay. So in 6 part A, we want to, excuse me, simplify this expression. Sorry about that. So when they say simplify, what they really want you to do is eliminate all the i's from the denominator, right? And so the most important relationship that you'll see with complex numbers is, I squared equals -1 and I is just the square root of -1, which is really weird, right? Because we're told that this can't happen, but with complex numbers, anything is possible. Okay, so how do we do this? Well, let's multiply by the conjugate, okay? So we multiply by a factor of 1 where we look at the denominator, change the sign, and then multiply by a factor of 1. Okay, and so here we can just expand it normally. So you're going to get 1 minus 2i plus I minus 2i squared. And down the bottom, you've got a complex number times its conjugate, right? So again, you'll see some nice cancellation here. Okay, so I'm doing this the long way, but you can see these are going to simplify. These are going to disappear. and I squared equals -1. So this is going to all become real on the bottom. And that was part of our aim, right? So I squared equals -1. That's going to be 1 minus I plus 2. And down here, it's 1 plus 4. Okay? So now all we need to do is simplify this. And if you want to really write it out in true Cartesian style, you would break this up and write it like that. Okay? Now, that's a lot of work for a pretty basic problem. So what you can do is you can remember the following. If you multiply a complex number by its conjugate, you just get the square of the modulus, the square of the length. Okay, so for example, in the bottom part, it would just be 1 squared plus 2 squared gives you 5. So that's a real nice little time saver. You don't have to worry about writing all this stuff out. You just say, okay, well, that times the conjugate, you just square the coefficients or the real and the imaginary part and add them together. Okay, so that's your time saver there. All right. So part B is very similar to this. I won't do part B, but let's have a look at part 7. Okay, let's do A and B. They're pretty easy. Okay, so if Z is in Cartesian form, express the following in Cartesian form. So Z squared and 1 on Z. Now, the second part definitely lines up with what I just mentioned. Okay, so let's have a look at 7 and see what we can learn from that. Okay, so let me share my screen with you again. Okay, so if Z is in Cartesian form, consider this. So Z squared is going to be A plus IB squared. So you would expand this like you normally would. So it's A squared plus 2ABI plus IB squared. Okay, so this part's going to be real because I squared equals -1. So I'll move that bit over here. Okay, so this is going to be the real part, and this is going to be the imaginary part. Pretty easy, right? For part B, we've got 1 on Z. Okay, so the tempting thing here is to write out that, but it's not, you don't actually need to. So what you can do is just use the conjugate here. So we know from up here that Z times Z bar or Z conjugate is just the square of the modulus. So who can tell me in the chat, let's wake up everyone, what is the conjugate of Z? If Z's that, what's the conjugate? Who can tell me in the chat? William is right on it. Vrudant is right on it. A minus IB. And who can tell me what is the square of the modulus? If that's my Z, what is the square of the modulus? Who can tell me? Who can tell me? Yes, Vrudant, you are. Okay, and if you really wanted in proper Cartesian form, there. Okay. All right, so there's some basic entry-level complex number questions. Let's move on to some slightly different questions. I thought we could spend a little bit of time looking at these relationships here, maybe just the first two. Okay, so the imaginary part of z is equal to this, and the real 2 times the real part of z is equal to this. Okay, so let's look at some proofs for that and see how we do it. It's pretty easy. Okay, so let's have a look. So this is 16, and let's look at part A first. So consider, please. Okay, so the imaginary part of z. So we want to prove this. How do we do it? Well, let's look. First of all, let's write z in a say a Cartesian form, right? Who can tell me what is the imaginary part of this complex, this general complex number? Who can tell me? Who can tell us in the chat? Huh? What's the imaginary part of this thing? Yep. Thanks, Brudant. All right. So that's the left-hand side. The conjugate is not a plus b, it's a minus b. I mean a minus ib, sorry. Okay, so let's work with this z minus z bar. Okay, so z minus z bar is going to be that minus that. The a's cancel, and you're going to get 2bi. So you can see the two i's are going to cancel. And there you go. So the right-hand side of star equals the left-hand side of star. There. Pretty easy. Pretty easy, right? So this is the right-hand side of star equals this. Okay, so we both showed that they were equal to b, whatever b is. B is a real number. Okay, so let's do part B. That's pretty much the same. So it is 2 times the real part of a complex number equals z plus its conjugate. Okay, so again, let's use this Cartesian form for any complex number z. And 2 times the real part, that'll be 2a. Z plus z bar is going to be a plus ib plus a minus ib. So the ib's cancel. Let's call this double star. Okay, I did that one a bit quicker. Okay. All right, so who can tell me in the chat, have you seen this before? Have you seen polar form, modulus, and argument? Who can tell me in the chat? Have you seen that in lectures yet, in the algebra lectures? Yes or no? Have you seen it yet or not? Rudant says yes. Okay. So let's talk about that. Let's talk about number 20, I think. That's a good one to think about. So you've got a complex number. Calculate the powers from 1 to 10. Plot them on an Argand diagram. Is there a pattern? What is the smallest positive integer such that the power is real? Okay, so let's have a look at that. And then after I've done this question, I want to hear from you. Okay, so we can turn this into a bit more interactive and I can hear from you. All right, so let z equal 1 plus I. And consider the powers. Okay, that's a lot of calculations. But what we can do with our polar form is to work smarter, not harder. Okay, so remember in polar form, you've got a length and an angle. Okay, so this is like the real axis and this is like the imaginary axis. Okay, and for this complex number, what we would like to do is turn that into a polar form. Okay, so you've got the angle theta, you've got r, which is a distance to the origin. Who can tell me what is r and theta for this particular complex number? Who can tell me in the chat? Come on, there's 11 people here. Oh yes, William. Prudent. So root 2. So if that's 1 and 1, the hypotenuse is root 2, right? So, and the angle is pi on 4. So instead of, instead of making that to the power 10 or something, let's see how easy it is with the polar exponential form. Okay, so you get something like this, which is brilliant, right? Because now you can write it as something like this. So the J is going to go in there. Okay. Yeah, Alan, it's quiet today here. The last tutorial I gave was super quiet. I was even messaging students individually and they weren't responding. I was so sad. So sad. Oh, maybe yeah. Why? And hopefully they've all finished by now. All right. So that's it, right? That's the format. And then is there a pattern? Well, we can see what's happening. So that's the first one. And then that's for j equals 1. For j equals 2, we go up there, right? And then for j equals 3, you go up there. And then j equals 4, you go over there. So there is a pattern. Each of these angles are equal, and the length increases by a factor of root 2, I think. Okay. So when is the first real, purely real number here? Well, j equals 4, because it's 1, 2, 3, 4. That's negative. Okay. Oop. Okay. So that's it. I haven't plotted them correctly here, but you can do that. You get the idea. Okay, so even that was a hard question. It was pretty easy. So the pattern is the complex numbers angles keep increasing by pi on 4 but through every power, and the lengths increase by a factor of root 2. Oh, William, so just put in some numbers. Okay, so when j equals 1, the argument is pi on 4. That'll be pi on 4, right? When j equals 2, it'll be pi on 2 up here, right? Like when j equals 2, you get a half, and it's multiplying by pi. So that will go up there. Okay? And then for j equals 3, this angle will be 3 pi on 4, which takes you over here. For j equals 4, these things cancel, and the angle is pi. Yeah, I know. Like, William, are you studying engineering by any chance? Are you in the engineering program here? William, are you in the engineering program? Oh, yeah. So that makes sense, because in engineering, J plays the role of I, right? So if you're studying engineering, all your like some of your lecturers will say, J squared equals -1, yeah, but not in maths, okay? But not in maths. Maths we use I, okay? So it's very confusing if you're doing engineering, because you have to switch between the two. All right, folks, the tutorial is half over. So now what I would like to do is to hear your questions. What questions do you have for me? If you want to turn your microphones on, you want to talk about anything, it's now time for Ask Me Anything. You can ask me something about the writing assignment. Let's look at the writing assignment. Oh yeah, well, good question. This is a quokka. It's like a very small kind of rodent or kangaroo. Let's mix them up. Let's make them fight. How's that? Yeah, battle. Yeah. So they'll battle, Frudan, and let's see if there's a winner at the end of the class. But ask me anything, people. Let's go and have a look at the. I think the writing assignment has been. Oh, it's been released. It's been released. The assignment is out. Let me go and share it with you. Assignment. Assignment. Okay, so the deadline is week 8, Tuesday. Okay, and you can use MS Word or LaTeX. And here's the assignment information. Okay, so the most important thing is your solutions must be typed. Okay, and everything needs to make sense, like the grammar, the English, the punctuation. It all needs to make sense. Okay, and so here's some of the ways that the marks are distributed. Your submissions should be written in full sentences. They'll look at the correct, like if the mathematics is correct, and the clarity of your arguments and the written expression. So you need to type. And you can see, here's an example, right? Here's an example of some mathematical writing. The sentence starts with a capital letter. It ends with a full stop. Okay, so you get 0, 1, or 2 for each part of the assignment. 0 if there's no sentences, 1 if there's some sentences, 2 if it's perfect. Okay, and it's the same for all the other parts. You know, the mathematics is correct. The solutions are self-contained. So very few people get full marks for this assignment, right? I think Google Docs is okay. It has an equation editor, so it should be fine. Vuldat. Okay, but it's, you know, a lot of people they don't see the, you know, the little mistakes that they make, especially if English is their second or third language. So, you know, are the equations typeset using an equation editor? 0 if they're none. 1 if some are done and but not all. 2. Okay, so this will take you some time, and I know it's hard because you just finished lab test 1, but you have how many weeks? I think 3 weeks, almost 3 weeks to submit this. Okay, so when I say typeset, I think it's just typed with a program. Okay. So yeah, so Denzel, I think that's my advice. Just be really careful checking all your work against the five elements here, right? So correct sentences and paragraphs, you know, clarity, self-contained, correct mathematically, and proper typeset. Okay. Wyan, I think like hardly anyone gets 10 out of 10. Like almost nobody gets 10 out of 10. I would say the average would probably be around 8, but I don't know for sure. I'm just guessing. I think around 8. Because what happens is hardly anyone gets 2 out of 2 for everything. So people lose at least 1 mark on something, and sometimes they lose 1 mark here and 1 mark there. Okay, so I think about 8 is about average. Does that make sense? So where is the oh, it's in Mobius. Okay. Let's go have a look. Should we go have a look? Let's see if it's there. Oh, everybody's logged on, finishing their lab test one. Mobius won't let me. Oh, 2020. I don't want that. I want term 3, 2021. Thank you. No wonder it was so slow. Oh my goodness. Is anybody in Sydney here at the moment? Let me know in the comments if you're in Sydney right now. Who listening in is in Sydney? Because there's an important message. Rudant, William. Okay, there is a tornado warning for Sydney at the moment. I don't know if you saw that, but there's a tornado warning. So yeah, watch this space. Oh, Rudant, is your house okay? Was there any damage? Oh, good. Where I live, I don't have a garage for the car. And so the car just gets parked on the street. So I'm always worried when there's hail that the car's going to get ruined. Okay. So I think you just choose one of these, right? And you choose one of them and you just look at the questions and solve them. There's pure math, engineering math, economics, chemistry. So you just choose one, and I think it's 3 questions. Okay. So you can choose the pure math one or the engineering one or the economics one, but you just choose one of them. Okay. Should we go and have a look? Let's go and have a look. Oh, let's do the pure math. Oh, I don't satisfy. Why not? I'm requesting an exception. Oh, I got no idea. Oh well. Looks like I don't fit it. So anyway, I think the most challenging thing with the assignment is actually the typesetting. You know, getting all the equations looking good and all that sort of stuff. So the mathematics is not very difficult, and you can check the mathematics on Maple. There is the "How did I do" button, but you don't submit it. You have to submit it in a separate document, right? Oh, declaration. Do I need to do that? Oh yeah. Well, no, I think no, I've done the declaration. Oh, okay. Oh, okay. Let me just do that now. Oh, okay. Whew. I agree. Okay, let me just. Okay. Oh no way. Can you hear the thunder? It's about to. I passed. Woohoo! Okay. No, I think Theo, you can have a look around. I think you can have a look around. So, do you want me to see? I'll try it. I'll just try it now. So let me see. I think you should be able to look around. I would be uncomfortable if you couldn't look around. Try before you buy, right? Oops. All right. So let's go and have a look. Should we go and have a look at the pure math one? Ah, oh, thank goodness. Okay. Blah blah blah. Let's go have a look. Okay. So that's one. And oh, so there's 3 questions. Okay, there's that one. That looks like a vector question. Okay. and there's that one. Okay, so let's go back, see if we can jump into another one. Theo, is there any one you want me to look at in particular? Let me know in the chat. No way, the thunder's just raging around me at the moment. Electrical engineering. Okay, let's go have a look at that. Yep. Can I start it? Yeah, I can start it. Do. Bump, bump, bump. Oh yeah, looks kind of the same. Looks kind of the same. Oh, there. So okay, so it looks like the last question is different. That's probably true for all of them. Okay. So the first two questions look very similar, and the third one looks different. So this looks more like it's about circuits, yeah, and some differential equations. Okay. So it looks like you can try before you buy. You can surf around. All right, people. What do you want to talk about? What do you want to talk about? There's like 10 minutes or so left. What would you like to talk about before this tornado comes and sweeps Sydney away? Let me know, people. I'm here for you. Ask me anything. Ask me anything. You can turn on your microphone, turn on your video if you want. Looks like there's not much action happening over here, but Rudan, Freedom Day is kind of interesting at the moment. You know, none of us can go to a different state or get on a plane and leave the country. So I have been out today. I went to the hardware store, but that's as free as I've been. That's as free as I've been. Um, Denzel, you can use graphics calculators. Um, and so I would think if you had the GeoGebra app, you should be able to use that. Let me just have a look. I'll just see if I can find something. Okay, so you can use any calculator you like. So this is from the course authority. Here we go. Let me put this up. So here's a message from the big boss, Jonathan Kress. You can use any calculator you like in the tests and exams. In one of the tests, you'll need to use Maple. That's lab test 2, which you will learn about in this course, but generally any calculator will do. But for many parts of the assessment, the emphasis is on understanding rather than calculating things. So we are happy for you to use whatever tool you like to do basic calculations. Okay? So you should use, and their advice is you should use it as a labor-saving device. So, so to answer your question, which is a good one, Denzel, I think you can use it, but you'll definitely need Maple because Maple will be able to do things that GeoGebra and graphics calculators can't do. Okay. But I love GeoGebra. GeoGebra is like I think it's brilliant because it's so easy, and I mean you can even just do it on your phone, right? Like it's amazing. Okay, people, ask me anything. Let's go. Ask me anything. AMA. Ask me anything. There are 11 people here. Ask me anything. All right, William and Alan, can we do a question on Cartesian form of planes? It's the only part of the lab test I struggled with. Yep. So, Alan, I think in lab test 1, you can just do the calculations by hand. In lab test 2, it's going to be harder. Okay. So you'll definitely need Maple in lab test 2 and the final exam. You won't be able to get away with doing things manually, right? Because they'll ask you all sorts of crazy questions that you can only do in Maple, right? So you'll be able to have a practice exam and you'll be able to see the level of difficulty. Okay. Okay, William. In the test, I think they gave Cartesian form and one vector, and they wanted you to find a point and another vector. William, why don't we have a look on let's have a look on the questions for chapter 2, and you can tell me which one is the closest. Okay. So let's have a look at, I think, you got the cross product. We've got the scalar triple products, planes. Here we go. So, William, let me know if anything is coming up here that is similar to what you saw. Okay. So you're saying in the test they gave Cartesian form and one vector and wanted you to find a point and another vector. A point on the thing. Okay. I think we can work with that. Let me see if this is right. Oops. Oh, hang on. Just got to turn my document camera back on. Okay. So what you're saying is that, let me just share. So if you're saying that you're given something like this, yeah, and you're given one vector that's parallel to the plane. So let's say that's your plane equation. And A is a point on. So what are they asking you to do there? Find a point and another vector. Okay. Is that right? Yep, you can just sub in some values. So you want to find is that right? So you want to find a point on this and you want to find another vector that's parallel that's not this one. Is that right, William? Okay. So what you can do is say and Rudan is right on point here, let y equals 0, let z equals 0, and find the value for x. Okay, so for A, let y equal 0 and z equals 0. So x is going to be d over a. So a is then a point for a is just that, right? Okay. So you said you got that, which is good. For your problem, A, B, C, and D would be particular values, right? So how can we find this second vector? Anybody know? How can we find a second vector? Brudan, I think, yeah, that's one way of doing it. I think there's even an easier one. I mean, what about, can we just convert to parametric vector form? Is that, I mean, I think that's a pretty easy way to go from here to parametric vector form, right? Like, isn't that what we've been doing a lot in the like, at least you should have been doing that in the algebra lectures. Okay, so I mean, if you have something like you know, hang on, let me find a piece of paper here. If you have something like this, say 2x, well, actually, let's just do x plus 2y plus 4z equals 3, right? You can introduce these, oh, that was thunder. These two parameters. So it's going to be 3 minus 2 lambda 1 minus 4 lambda 2. So you've got this for your y, this for your z, and that for your x, right? And so if you write it as a column, it's going to be, and you just break that up into 3 parts. Negative 4, 0, 1. That's it. Okay. And so getting back to your question, William, one of these vectors, or at least something very similar to those, would be already given to you. Okay. So what you would do then is say, oh well, this other vector is the second vector. Ah, don't worry, Vrodan. We want you working smarter, not harder. Okay. Don't worry. But this is, you know, this is the way to do it. I think that's the way they want you to do it. So hopefully that makes sense, William. You know, obviously, it depends on what these two things are at the start, but you know, I think that's the way they want you to do it. Okay, everyone, there's 1 minute left. Ask me anything. Ask me anything. 11 people here. Ask me anything. It's the last chance before week 6. Well, week 6 is next week, and it is flexibility week. Yeah, I hope you get very flexible in flexibility week. Okay, let's ask everyone. Do we have it? You decide. Ooh, everyone's got an opinion now. Is it the quokka or is it the spider? Who wins? Who wins? At the moment, the quokka wins at the moment. Okay, 3, 2, 1. That's it. Quokka wins. All right. I won't see you next week because there's no classes, but I will see you in week 7. So no classes in week 6. So have a good flexibility week, and yeah, I'll see you in week 7. Okay. So have a great time off or whatever you're going to do, and yeah, stay safe. And I will see you in week 7. All right. Thanks, Ruda, Denzel, Adam. Bye, everyone.